Series brought to you by the North Carolina Museum of Natural Sciences and the North Carolina Office of Environmental Education. It's good to be with you again on another Wednesday afternoon. Hope that you had a great long weekend, enjoyed your holiday. Now we are headed into the official part of summer. So it's great to be with you all. And in thinking about summertime, it's gonna get hot. Undoubtedly, especially in and around Raleigh, I think. But well, no, I think everywhere. Climate change is doing that for us. It's going to be hot everywhere that you could possibly imagine, I think. So today we're going to be talking a little bit about things heating up. We've got three special guests for today's presentation. Before I introduce them, though, I want to remind everybody that as we go throughout today's presentation, make sure that you're dropping your thoughts, questions, and comments into the chat as we go. I'll be moderating your questions back to our guest presenters today at the end of their presentations. So the Lunchtime Discovery Series is interactive, so please interact. Let me introduce today's guests because I want to give them plenty of time to share their knowledge and expertise with us. We'll be hearing from three guests. First off, you'll be hearing from Max Cawley. He's with the he's with the Museum of Life and Science. I almost messed that up. Museum of Life and Science in Durham, North Carolina. Chris Goforth is the head of citizen science with us at the Museum of Natural Sciences. And we'll be hearing from Myleigh Neill with the State Climate Office of North Carolina. Welcome, all three of you. It's good to have you here.
Hey, Chris, thanks so much. Yeah, there's a little bit of a long-time listener, first-time caller feeling here. I'm a big fan of yours and a big fan of the show. So thank you so much for the invitation. Yeah, so I'm really thrilled to be here. And actually, this is an invitation to all of y'all that are participating, listening at home with us. Today's talk is going to go sort of in a backwards direction. I'm going to start by talking a little bit and inviting you to join us in an exciting and important project this summer that my colleagues Myleigh and Chris and I are participating in. And then we're going to talk a little bit about some of the rationale behind some of that project. So this project is happening concurrently in 11 different states across the United States. I'm going to share my screen and show a map. Give me a thumbs up if you can see my screen. Okay, we can see my screen just fine. That's awesome. So this project is happening concurrently in 11 different states across the United States and has happened over the past couple of years in a couple dozen cities. It's made possible by NOAA and NIHHIS. NIHHIS is the National Integrated Heat Health Information System. It's kind of a mouthful. And also a public-private partnership with CAPA Strategies. And the basic goal of this is to map urban heat and urban heat islands. We'll talk a little bit more about urban heat sort of as a climatological phenomenon, but it's important to start out with sort of an acknowledgement that urban heat is not just a climatological phenomenon. It also has implications, obviously, for urban development, for strategy, for governance, but also for things like social, racial, and economic justice. And it also has very close tie-ins to local histories in each one of these places. And in particular, some of the painful legacies and histories of things like redlining, discriminatory policy, and racist planning and policy decisions made in a lot of these cities that this is taking place in. The essential goal of these is to look at how urban heat is sort of expressed over an urban area, because heat, as we'll learn soon from my colleague Myleigh at the State Climate Office, is an increasing concern in a warming world. But it is not expressed evenly or equitably across an urban environment. There are specific people, as we'll learn today, that are more at risk during extreme heat events or heat waves. Our project aims to take this study sort of outside of just the realm of scientists doing research and doing research in a community-driven way. So it will engage the public, non-scientists, in monitoring the communities and neighborhoods in which they live. So our local project is happening in Raleigh and Durham this summer. It will engage people, the public, you potentially in monitoring what heat feels like on a very hot day here in Raleigh and Durham. Specifically, we're aiming to monitor around 130 square miles and get really nice and granular data about how heat is expressed across that area. Because again, as we'll learn throughout this presentation, there are a whole bunch of different factors that play into not only how hot or cool an area is during a heat event, but also how vulnerable people are during those heat events. So that monitoring event will happen sometime this summer, and I hope to give a little bit more information about some of what that will look like. But while we're looking at these photos, I want to mention and thank my colleagues Myleigh and Chris for spending some time with us to talk a little bit about some of those important intersections with extreme heat and about this project that we're undertaking together. I also want to acknowledge sort of upfront that this builds on a lot of the expertise and work of some of our colleagues, in particular, Dr. Vivek Chandas with CAPA Strategies, Dr. Jeremy Hoffman at the Science Museum of Virginia, and also Dr. Angel Xu, who's over at UNC, who published a study that we'll be talking a little bit more about today. But without further ado, I thought that I would turn it over to my friend Myleigh so that she can give us some of the sort of climatological context for this project. Myleigh, go ahead and take it away.
Sure thing. Thanks, Max. So hi, everyone. My name is Myleigh Neill. I work as a research technician for the State Climate Office of North Carolina. I want to start off by talking a little bit about the climatological side of extreme heat and about urban heat islands. So I'm going to go ahead and share my screen. Okay. There we go. So what is the purpose of studying extreme heat? Something that many people may find surprising is extreme heat is actually the #1 weather-related cause of death on average. So more than flooding, more than lightning, more than tornadoes. And that's a big reason why it's so important to research extreme heat. So in this graphic by the National Weather Service, who are actually another one of our partners on this project, the yellow bars show the 30-year average of weather-related deaths in each category between 1990 and 2019. So that tallest yellow bar there in the middle is the heat category, followed by flood on the far left, then tornadoes, then hurricanes and lightning. So the significant impact that heat has is one reason why it's really important for us to research it. So what is extreme heat? Extreme heat can be defined as temperatures that are much hotter or much more humid than average. So humidity is a factor since high humidity can make it feel hotter than what it actually is. So since some places are hotter than others, it really just depends on what's considered average for a certain location at that time of year. And anything that's significantly above that average is considered as extreme heat. So this is a graphic which was created by a local meteorologist in Raleigh, which shows the increase in the average number of days above 95 degrees Fahrenheit in the Raleigh-Durham area, which is generally considered as extreme heat for our area. So since the 1970s, we average about 18 more days per year with a high temperature of 95 degrees or hotter. So how do we forecast extreme heat? Using climatology, we can predict when the hottest periods of the summer will most likely occur. So typically in climatology, we use 30-year averages to define what the climate of a region is like. So by averaging the daily maximum air temperature of a location over a 30-year period, we can see when the hottest days of the summer are most likely to occur. So for the Raleigh-Durham area, we know that this period of the summer generally falls between mid-June and mid-August. Climatological predictions reflect averages and not necessarily the day-to-day fluctuations. So this is where weather forecasting comes into play, usually by the National Weather Service or your local TV meteorologists. They forecast the day-to-day weather patterns and can give you a pretty accurate weather forecast several days in advance, such as letting you know, for example, that a high atmospheric pressure might be moving over your area, which would drive up the air temperature during those days. So let's look at climate trends. The IPCC, which stands for the Intergovernmental Panel on Climate Change, publishes an assessment report every 7 years or so that explains in detail the current scientific understanding of climate change. So in the most recent report, the authors noted a few significant things. One of which was that changes in many extreme weather and climate events have been observed since about 1950. Some of these changes have been linked to human influences, including a decrease in cold temperature extremes and an increase in warm temperature extremes. They also noted that the surface temperature is projected to rise over the 21st century under all scenarios, and that it's likely that heat waves will occur more often and last longer. So let's move on to climate trends in North Carolina specifically. As of the most recent North Carolina Climate Science Report, which was released last year in 2020, the period of time 2009 to 2018 was the warmest 10-year period on record in North Carolina. 2019 was the warmest year on record for North Carolina, and it was the second warmest year globally. So this being said, daily high temperatures are actually not the only statistic that's important to think about when you're thinking about changing temperatures. In North Carolina, it's important to note that overnight minimum temperatures have actually been getting hotter. So the years 2015 to 2019 had the warmest overnight low temperatures on record in North Carolina, with 2019 actually setting the record for the warmest lows in the recorded past. So the climate scientists that wrote this report found that it was very likely that North Carolina temperatures will increase substantially as a whole, and specifically that there will be an increase in the number of warm nighttime temperatures. And similarly to the rest of the globe, they also found it likely that North Carolina will see a decrease in number of cold days per year and an increase in the number of hot days per year. Okay, so to finish up my part, I want to talk a little bit about what an urban heat island is and what exactly it is that we're studying with this project. So the term urban heat island refers to the fact that cities tend to get much warmer than their surrounding rural landscapes, especially during the summer. In urban areas, hot days can be amplified by paved dark surfaces like roads and buildings. They absorb and radiate more heat than the green landscapes that might be around them that have trees and grass. So that increases the urban temperatures. So you can kind of think about this in a context of wearing a black shirt on a hot day instead of a white shirt. You'll get much hotter wearing the black t-shirt. And it's the same way with having dark spaces rather than green spaces in cities. The dark spaces get much hotter than the green areas do. This difference can cause some neighborhoods even to be 20 or so degrees Fahrenheit hotter than other neighborhoods which are within the same city. So this map here is Richmond, Virginia, where they've run urban heat island mapping campaigns over the last few years. So this map shows the temperature increase from morning to afternoon over parts of their city, where the darker red colors are larger temperature increases over the course of the day. So this is really valuable information, and this map is pretty similar to the type of data that we will be able to get out of the mapping campaigns here in Raleigh and Durham as well. So I guess with that, I'll go ahead and turn it over to Chris to talk about why it's important to study extreme heat.
All right, thanks. I'm going to share my screen here as well, but while I do that, I'm Chris Goforth. I'm the head of citizen science for the North Carolina Museum of Natural Sciences. And can you all see that? Oh, hold on. Sorry, I think I've got my presenter view. Can you see my presenter view?
Yeah, that's what
All
we're
right,
saying.
hold on. Sorry, I forget my my dual monitor thing doesn't work always. The way
Every
it's
time.
supposed
It happens every time.
Give me 1 second. Anyway, my job at the museum is to connect people with opportunities that they have to participate in scientific research. And so this is one way that you all can help us do some research, and we're very excited to make this a participatory thing. So we want to talk about why this is important. All right, better? All right.
Perfect.
So as Myleigh said, you know, the impacts of urban heat islands are such that you have more heat trapped, like in the city and in suburban areas than you do in the surrounding rural areas. And so there can be a very big difference between green spaces and more paved spaces. And overall, it just disproportionately impacts certain areas more than others. Myleigh also talked about how the temperatures are going up, and so we know that things are getting hotter, and so the impacts of this urban heat island effect can become much more substantial as the temperatures go up. And so the people that are in those areas that are most heavily impacted by urban heat island effects are potentially going to keep getting worse as the temperatures go up overall. We also know, as Myleigh also hinted at, that there are certain areas that are more heavily impacted than others. And so that, you know, has climatological impacts, but it also has social impacts. So this is New York City, and you can see kind of the differences in temperatures. So there are people that live in these red areas that are more heavily impacted by that extreme heat effect than the people in those more blue and green areas. And so there are people that live in those spaces that are disproportionately impacted by these urban heat island effects. And so we are hoping to collect data that will show us where those areas are in our own spaces so that we can potentially help mitigate some of those impacts. There are a lot of different impacts of urban heat islands on people, and some of these are really important. So one is that the energy consumption goes up a lot when you have these urban heat island effects. So you have more heat trapped in cities, which means more people are turning on air conditioning units and other cooling units. It requires more energy to run refrigerators and other cooling devices. And so the overall energy consumption just skyrockets during really hot days. In some places, that means that the need for power actually exceeds the available power. And so you'll end up with blackouts in different areas. And there also become issues with affordability for some people. If you can't afford to run your air conditioner full blast all the time, or can't afford to have an air conditioner in the first place, then that means that these really hot days impact you differently than people that can afford to have their air conditioner on. You also see increases in air pollution and greenhouse gas emission, and these tend to get kind of trapped in these urban areas, and so the air quality can go down pretty significantly on really hot days. I know we get, you know, ozone warnings in our area, but there are lots and lots of different things that are emitted by our cars and our air conditioners and other things, you know, that impact the air quality in our area. You can also see decreased water quality. Anytime you have really warm temperatures, that decreases the amount of oxygen in a body of water, and it just overall impacts the water quality in an area. And then, of course, you also have human health and comfort decreases. So, we don't particularly like being hot. Most people don't like being hot. So the comfort issue is there, but there are also real health risks for people that are in areas that are particularly hot. So some of those health risks as the temperature goes up are you see increases in health-related illnesses. You see definite increases in heat-related deaths as well. And Myleigh pointed out that this is the biggest climatological risk for human death. You can see increases in respiratory stress for people as well. And then overall, people are just less comfortable when it is particularly hot outside. We're really built for kind of a certain temperature range. And if it gets above that, we start getting really uncomfortable. There are also disproportionate impacts on particular people in these extreme heat events. So children are heavily impacted. Older adults are heavily impacted. People that have pre-existing medical conditions can be disproportionately impacted. And there are people who are, there's a range of affluence that is impacted by these events as well. So people who tend to have more affluent living conditions are usually a little bit less impacted by the heat island impacts than people who are less affluent. So again, those people that can't afford to run their air conditioners or live in less affluent neighborhoods tend to have fewer green spaces. They tend to have more pavement. And so the temperatures in those neighborhoods can be more, and you also have less money potentially to help overcome some of those issues that are associated with that extra heat. So we have all these different issues of this heat getting trapped in cities, but we really need your help to help us study this. And so we are using a citizen scientist approach or citizen science approach for this study. We want to have people help us do this work. So it's not just us. So citizen science is a way that people can get involved in scientific research, regardless of their level of scientific expertise. These are projects that are open to participation by everyone, regardless of their level of experience in science or their degrees. And this is a project where we want to have lots and lots of people involved. So we want to do this data collection with everyone. This participation is going to help us in a lot of different ways. So for one, you heard that we have 130 square miles that we're trying to cover. We need lots of people to do that. It can't just be our little team doing it. We're not enough people to do this on our own. We need lots of people to go out and help us collect this data. You'll also hear a little bit about the logistics of how this is going to work in a little bit, but we need multiple people going out at the same time in lots of different areas so that we can get really good coverage in our area and produce a really great heat map. We can also allow people to collect data in their own neighborhoods in this context so that people can actually see what is happening in their own area and potentially gain knowledge about their own space that they can use to help mitigate some of these effects for themselves. And then we're also generating a data set that will help us address some of these issues. So we have resilience planners in both Raleigh and Durham that are planning to use the data that we collect so that they can actually help try to solve some of these problems. So if we have areas that are disproportionately impacted by these heat island effects, we can look at those neighborhoods and figure out ways that we can try to solve some of those issues. So there are lots and lots of different ways that we can kind of reduce that urban heat island effect in different areas, including some of the ones on the screen now. And so some of these are things that people can use to take our data and actually apply it to our area and try to solve some of these problems. So maybe our heat island impacts will be a little bit reduced over time. All right, I am going to turn it over to Max, who is going to share a little bit of information about the project and the environmental justice impacts of this work.
Hey, thanks, Chris. Cool. Along with being a great way of collecting a lot of data, I think this is a really exciting model for doing more open and equitable climate work just in the future, having more participation and broader participation in science from non-scientists as well. So I'm very excited and think this is a really fascinating and excellent new model for how this type of research can be done. I'll also say that I think there's really good reason to be hopeful with types of projects like this. So the ambitious project that I hope you'll embark on or consider embarking on with us has been impactful and influential, not only in building new knowledge around local and hyperlocal impacts of extreme heat, but also in building resilience, fostering, establishing, and strengthening partnerships, and advocating and creating policy, action, and infrastructure around making cities more equitable, just, sustainable, and livable for everyone. And I think the key that you probably heard from Chris and Myleigh is that our cities are not those things right now. Data from the type of study we hope to do, which I promise I'll talk more about in just a moment, suggests that when it comes to environmental and climate phenomena like extreme heat, we're living in cities that are not equitable, that are not just, that are not sustainable, and tragically not livable for many people. The disparate impacts of extreme heat are specifically and disproportionately dangerous to poor communities, to Black communities, to Latinx communities, to communities that people of color inhabit, to communities with higher levels of undocumented people. These communities are not only more likely to be literally hotter because of the built environments around them, but are also the least invested in preparing for heat, which makes for a really terrible convergence and higher risk for heat-related illness and death. So extreme heat is a climate phenomena, as Myleigh and Chris told us. Across just about every metric that you could use here in North Carolina, we can expect more extreme heat events into the future. What counts or gets classified as extreme heat is complicated, and it's based on metrics that you've heard my colleagues talk a little bit about already. In terms of climate trends, under any emission scenario, we can expect to see more days over 95 degrees, more days over 100 degrees, more days over 105 degrees, higher low and nighttime temperatures, which are crucial for cooling the human body down. One of the most terrifying ones for me is under a higher emission scenario in North Carolina, by the end of this century, we may be facing down up to 140 days where the temperature climbs into the 90s per year. And it's important to keep all of these in mind. So even if a 90-degree day doesn't seem or feel as extreme as a 105-degree day, each of these can be hazardous or deadly under different scenarios. 90-degree days can be dangerous or deadly if it stays 90 degrees for days or potentially weeks at a time, if the nighttime temperatures aren't decreasing, if you work out in the hot sun, or if you can't afford air conditioning. These are important, if different, ways to think about extreme heat, and are just as important as thinking about those extreme heat days where it's reaching into 100 or 105. It's also important to consider that these require different types of adaptation and mitigation for them. What's needed for a long string of 90-degree days might be distinctly different than what's needed for a short-term event in the 105 to 110 degree range. It's really important to think about plans for both. So very recently, the New York Times reported on new research published by the NIH, which importantly, it had this important and sort of catchy headline. The author of a new study said the combination of blackouts and extreme heat may be the deadliest climate-related event we can imagine. Now, extreme heat is actually already deadly, including where we are here in North Carolina. There's an estimated 3,000 emergency room visits related to heat on average each year. So this, paired with the fact that climate is exacerbating heat events, means we'll see more of them each year. And the fact reported about in this article that power blackouts have increased in cities by upwards of 60% since 2015. And that the risk of a blackout paired with a severe heat event is, in the words of one of the authors at the Georgia Institute of Technology, increasingly likely. Now, this kind of makes sense, like Chris told us before. During a blackout, everybody rushes to crank up their air conditioning. But it's not just the power grid that's under stress. During some major heat events, like the tragic and deadly event in Chicago in 1995, people opened up fire hydrants to cool off, which decreased citywide water pressure and access to life-preserving water during a heat wave. Now, the science behind urban heat and urban heat islands, which you've heard my colleagues talk a little bit about, is relatively simple on a large scale. Hard surfaces tend to be hotter than soft surfaces. Dark surfaces tend to be hotter than lighter surfaces. Hard, dark surfaces are hot. Shade and green spaces tend to be cooler. In places where there is a lot of hard, dark surfaces and less shade, the built environment that we've made in cities absorbs solar radiation that creates an area that can be 10, 15, or sometimes even 20 degrees hotter than areas just blocks around it with more shade. So in this way, yes, extreme heat is a climate event, but it's not just a climate issue. Like Myleigh told us, extreme heat is the most deadly weather and climate-related event in the United States. It kills, by some metrics, perhaps 12,000 people or contributes to that every year, and not always in ways and situations that you might expect. People with health conditions, elderly people, very young children, people who work long hours outside, all of these people are at more risk from extreme heat. In that way, extreme heat is also a public health issue. As noted before, though, extreme heat is not felt or expressed evenly or equitably across environments, especially urban environments. Extreme heat is one of the ways we most directly see racist policy and planning playing out fairly directly as climate risk and hazard today. So yes, extreme heat is here, but how a person experiences it varies tremendously based on where they live and the conditions that they live in. And much of how people experience extreme heat is not related directly to climate change. It's tied directly to decisions that people in power made. And these decisions include the racial segregation of cities and policy and planning, like the Homeowners Loan Corporation, or HOLC, that divided up cities into color-graded zones based on racial demographics. This painful history of white supremacy and decision-making and planning meant that redlined areas deemed less desirable because they had more Black and brown people living in them did not receive equitable investment, and this included investment in the very things that we now understand to be important key mitigations against climate hazard, which includes extreme heat. This history of bad decision-making has played out so that many of these formerly redlined neighborhoods, rather than being a relic of the past, are today still poorer, disenfranchised, and lack the type of investment that helps build resilience. You can see this across a lot of different metrics. If you look at some of these formerly redlined neighborhoods and follow even some of the HOLC grades pretty neatly, even the canopy coverage goes from A, which was the neighborhoods that more white people were living in, have larger trees and more tree canopy, to the least trees and the smallest trees down in D. In that way, extreme heat is a social and economic justice issue as well. So our project hopes to look at a whole bunch of these important intersections and develop new knowledge and data to help inform better decision-making and planning into the future. Because of course, extreme heat is not just a climatological phenomenon, it builds on all of these histories and all of these other intersecting factors at play. Our project will develop maps like those that you see here, one in Washington, DC, one in Boston, and then the two down there in Richmond, that will be publicly available to people just a few weeks after the actual collection of this. Some of our partners on this project include Durham County and the city of Raleigh, and in that way, we are confident that they are listening and taking this seriously, and that some of these can be mainlined directly into policy and planning. But there's a purpose in having this live and be a public project as well. And that is, we want to collect these data with and for the people who need it the most. And so those people will have access to these data to use for themselves for advocacy purposes as well. Here's some of what we have found so far in Durham County. I believe later this week, actually, the Durham Community Health Assessment is going to be published, become final. And in it includes one of, if not the first chapters about climate change and public health in one of these documents in the Southeast. In Durham County, you can see all the way there on the left is the Durham County averages. So that includes things like the percentage of people living in poverty, the percentage of impervious surface, the percentage of canopy cover, the percentage of rentals, the percentage of people with no car, and the percentage of people with no health insurance. The other census tracts that you can see, which were collected from Durham's Neighborhood Compass, are some of the redlined neighborhoods, or the formerly redlined neighborhoods in Durham County. And pretty much across the board in these neighborhoods, if you look at these metrics, there are more people living in poverty. There is more impervious surface. There is less canopy cover. There are more people living in rentals. There are fewer people with cars, and there are more people with no health insurance. And that trend is seen almost entirely across the board, except for one where there is a census tract with a slightly higher than the average percentage of people with health insurance. All of these are social and economic determinants of health when it comes to something, a phenomenon like extreme heat. And a lot of that you can probably intuit based on what you've heard about already. The amount of canopy cover you live around, or the amount of green space you have in your neighborhood, is incredibly different important for how hot or cool physically your neighborhood might be. Areas with less canopy cover and more impervious surface, which again, across the board in these redline neighborhoods, we see less canopy and more impervious surface. Those areas are more likely to be hotter. And again, sometimes 10, 15, or 20 degrees hotter than areas with more cool space in the same city. But other things like whether or not you have health insurance, whether or not you have a car, whether or not you own your home, all of these are economic and social determinants of health as well. And all of these also play into how livable a heat wave might be for you. These play into things like whether or not you can afford to go to the hospital, or if you think twice about going to the hospital if you begin to get sick from heat, whether or not you can afford air conditioning, whether or not you have a social safety network around you. All of these play into your experience during a heat wave, which has to do with whether or not perhaps you are able to survive heat waves. One thing that I would have listeners of this program or participants in this program think about right now is, if you are not currently contextualizing a heat wave as something that might be potentially dangerous to you and your loved ones, something that might be potentially lethal to you and your loved ones, at least some of that privilege of not thinking of these as being extremely dangerous events has to do with the fact that you're buffered from that by wealth, that your wealth helps to keep you safe during these heat events. And if you are a white person like me, at least some of that wealth is generational or otherwise unearned. And in that way, there are really, really important other implications for these data when we think about what we can do after all of these data are collected. So let's go back to talking a little bit more about the project itself, because we've spent some time talking about why, hopefully, this project might be important to you and people that you care about. So hopefully you are perhaps considering, how might I get involved in a project like this? So we don't currently know exactly when our project will take place. So when we will send out these monitors into Raleigh and Durham. And the reason for that is we're looking for a hot day, which there are plenty here in Raleigh and Durham, but we're also looking for a day where it's not going to rain and where it will not be very cloudy. Myleigh and our partners at the National Weather Service are currently helping us to find a day like that. What we'd ask for you to do is consider joining our mailing list of potential volunteers, and then we'll let you know a few days before this event actually takes place. And we won't know for a few days because we're going to look for one of those very hot and very clear days, and that can really only be accurately forecasted a few days before. When the time comes, we will get back in touch and let you know, hey, this day is coming up. Remember this thing that you potentially signed up for that you might be interested in. Are you still interested in helping us to monitor extreme heat in Raleigh and Durham? we've split our study area up into around 15 different segments. And along those segments are some hour-long routes that we're going to ask volunteers to drive with a monitor that looks like the one you're seeing here in these photos. So these driving routes will be predetermined mainly around types of land use. So we are trying to have participants in this project drive past very, very cool, shady areas with a lot of green space, but also drive through areas that have very little green space and that have a lot of impervious surface. In this way, we will get both the land use of these cooler areas, but also the land use of these areas where we suspect it will be much, much warmer. This will help us to put together an accurate granular map of how heat is expressed across this study area, and will help our partners at NOAA, NIHHIS, and CAPA Strategies put together an excellent model that will show the warmest and coolest areas here in Raleigh and Durham. All of these data, like I mentioned, we believe are going to be very important, not only for policy and planning, just directly in the future with our partners in Raleigh and Durham, but also for advocacy purposes. And that's a big reason that we're so excited and happy to be involved today here and with you, Chris, in this lunchtime discovery, is that we do want to involve you, stakeholders, community members, active members of groups already involved in this work from some of the earliest stages of putting this project together, because we want this to be something collaboratively and publicly owned and useful. So many different types of involvements are interesting to us. If you want to use our data afterwards, we are really excited to talk with you about that. If you'd like us to consider some things about your neighborhood and the neighborhood you live in, or perhaps want to help us figure out what our routes look like, that's also something we're really, really interested in. If you would like to organize volunteers or work with your own neighborhood association around having monitors go out in your neighborhood, we're happy to talk to you about that as well. Because this is really only a first step of many. One of the last things I'll say here before sort of going into some questions, which hopefully there are some questions, I'm sure there are, is that I hope you'll consider joining this project, because there are so many more decisions that we can start to think about now at this stage of the project, with what happens to these data after they're collected and what we do with the implications. One important lesson that we've learned about resilience is that social isolation is exceptionally dangerous when it comes to climate-related events like heat. And this is one reason why community-based resilience strategies like buddy systems, check-in networks, expanding social safety networks, all of these are so vital within neighborhood groups and within communities to building resilience to climate change, to extreme heat, and to climate change just in general. The opposite of that lesson is also true. A partnership, collaboration, and engaged community in themselves are important resilience strategies. And that's a lesson that we want to take with us through this project, and a goal unto itself. We are hoping to create new partnerships, networks, and friendships. This project is built around and will be most effective when we involve as many people as we can in the different stages of this project, from designing the methodology to finding people and organizing around collecting data, collecting the data, and then using, disseminating, and talking about what we find. Ultimately, the broader the participation is on a project like this, the more political will can be created around doing something about a profoundly unequal planning and policy that has existed for too long here in Raleigh and Durham. So I'll end with, extreme heat is here, it's now. There's a lot of different things that we can talk about, and I think we have a few more minutes so we can talk about some adaptation and mitigation strategies potentially soon. But we have to do what we can to advocate, to understand and build resilience to this public health crisis. There are things we can start to do with these data towards building that resilience and directing, investing, and giving crucial resources towards writing the terrible decisions that got us to where we are now, towards making better and more informed decisions about the future. I'll go ahead and pause there and see if we've got questions. But I'll also, Chris, Myleigh, I'm happy to have y'all also talk a little bit about why and how you're excited to be involved in this project, and give a little bit more logistics, which perhaps I touched on, but perhaps did not.
Well,
So
big round of applause for everybody. And yeah, Myleigh, it looked like you're about to jump in, so take it away. I'll let you have it.
yeah, I was just going to throw one more slide up. I have our contact information on it in case anyone is interested in getting in contact with us. So give me 1 second.
Perfect.
Okay. So, okay. So this is our contact information. Definitely go check out our website. It's climate.ncsu.edu/research/UHI for Urban Heat Island. And then the email that you can get in touch with is info@activategood.org. That'll take you directly to one of our partners who can answer any questions that you have or forward your questions along to any of us and get you in touch with us. So there's that. I'll leave it up for a minute or two so anyone can take screenshots or write it down or anything like that.
Perfect. Thank you very much. Yeah, some of the questions that are coming in are about how to participate. So thanks for putting that on there. A question here, can you use help outside the Durham and Raleigh city limits in places like Chapel Hill or other parts even of the Greater Triangle area?
Yeah, what a fascinating question. I am very hopeful that a project like this will catalyze more studies like this outside of just Raleigh and Durham. Our study area is necessarily a little bit limited to what we're able to do based off of our support from NIHHIS and NOAA. Certainly, I would encourage you to sign up for our project and keep in touch with us because there are likely still important other pieces of this project that we do not have time to touch on today that we'd be happy to involve y'all in. And certainly, like I said, we understand and know that this is really just the first step of many towards building resilience around extreme heat. And Myleigh and our partner at Activate Good have done a really excellent job of curating resources around extreme heat that we hope will be really useful to folks.
Excellent. I'm curious about the particular sensors that you're using, this like PVC pipe sensor device thing, and the methodology on how you get reading. How do you know that everybody's just not, standing under a porch collecting all the readings and that they're, you get an honest assessment of the urban heat island effects or lack thereof in these places?
Yeah, really excellent question. Those monitors are collecting location data as well as various types of heat information. So as people are driving along these routes, it is also showing where exactly that data is being collected from. So that's part of the methodology of having people drive along very specific prescribed routes that we're currently in the phase of figuring out right now is we will be able to sort of track while people are driving and get really thousands of different data points along those routes as they're collecting them. It's not a terribly specific answer because there is a more specific answer. If folks are super interested in some of the mechanics of how some of that stuff works, certainly get in touch and we're happy to talk about it.
No, I think that actually answers the question because one of our viewers was asking, isn't it important to know where the sensors are? Because you could, if somebody wanted to, they could maybe manipulate the readings by just putting the sensor in a hotter or a cooler space. But I can see now if it's actually a device that records consistently as they're moving around a route, it's not about one point location, say in an entire neighborhood or a few, it's about a huge big area. Makes a lot of sense. Guess what, people? They thought this through, didn't they?
I will say too that there's always a question about data generated by citizen scientists, and I think it's been shown over and over and over again that in general, citizen scientists collect high quality data. Like most people have really good intentions; they want to do a good job. I know in my personal experience, it is like I see over and over again that people are so worried they're going to do it badly that they don't do it at all. And so I think we're going to get a really good data set from this because, the people that are going to participate are people that are really interested in this topic, that care about this topic, and want to do a really good job because it's going to lead to hopefully something really worthwhile and promote, equity in our area. So yeah, I think we're going to get good data.
Yeah, Chris, friend speaks my mind. I think you said it really beautifully. The data that will be collected is highly defensible data and very useful and usable data for planning purposes and for scientific research. So yes, it is being collected by non-scientists, but we have a pretty good understanding that that type of data is still very, very good data.
Collected by non-professionals. They are still scientists.
Chris, yes, friend speaks my mind. That's awesome. That's a good tip.
All right, let's see here. A question here, aren't many of the sensors that tell us the climate is warming in urban heat island areas? Or are they not? I think they're everywhere at this point.
I might point that one over to my friend Myleigh at the State Climate Office, if you feel like taking this one.
Definitely. So what we can learn, or how we can learn that the climate is warming is definitely there are sensors all over the globe. We have them, our office specifically has a mesonet of sensors all over North Carolina. A bunch of other states in the United States have these mesonets as well, which are weather sensors on towers located all over the state. I'm not sure if other countries have mesonets the same way, but I know that there are definitely weather sensors located all over the globe, out in the oceans, that can tell us that the climate is definitely warming all over the globe. Yep.
Yeah, excellent. Thanks. I'm curious about something though. It seems like we've got pretty fine scale satellite data that could give us surface temperatures. Why do we need individuals driving around cities collecting this information as well? Is the satellite data actually not as good as maybe I perceive it to be? What more do we learn by doing this a citizen science campaign like this?
I have some thoughts, but I'm going to turn it over to Myleigh again to see what your thoughts are from a State Climate Office perspective.
Yeah, satellite data is good. It's very good, but it is not as finely scaled as data that we can collect on the ground. So by putting sensors on our cars, driving around the city, we will get a much more detailed picture of where the hotter areas are and where the cooler areas are than something like a satellite could give us. So it really just comes down to the details.
And it is that satellite data is incredibly good, especially for things like regional temperatures. This project in particular aims to look at local or even like hyper local, so block by block levels, with the intention of better understanding what extreme heat looks like on a very, very localized scale, and how people living specifically in various blocks in neighborhoods in urban areas experience that heat. And that's not the type of granular data that we can get yet from those satellites, but is something that we'll be able to generate with a project like this.
All right, excellent. Next question in the chat. Do you have a plan for communicating the results to planners? It seems like this would further demonstrate the importance of urban parks and green spaces.
Yeah, so I'm glad that came up, because we are currently starting to think about what some of the adaptation and mitigation strategies that come out some of the implications of the project might be. So once again, some of the project partners from the very beginning have been Durham County and the city of Raleigh. And again, by having them involved, we sort of have a pretty good understanding of how this might be useful and usable for them later on. a lot of what gets focused on after these type of data are created is sort of that specific type of thing, urban forestry, creating more green spaces, things like that. And that is so vitally important, because planting more trees and creating more green spaces is extremely important for finding a way out of the current situation that we are in, which is that urban areas have huge unbroken areas of no green space, of no canopy, and of a lot of impervious surface. So we do have a way of communicating this with policy and policymakers and planners after the project is over. We are also thinking about and planning on trying to communicate this more broadly and publicly so that it is useful for other mitigation strategies that perhaps might be a little bit less immediately obvious. And that includes things like local level advocacy for increased capacity for communities to decide or have power over what the mitigation strategies happen within their own communities are. And that comes down to the fact that resilience is about more than just things like urban forestry or infrastructure, but also boils down to dismantling racism very specifically for something like urban heat. It also comes down to bringing people out of poverty. It also comes down to a lot of the different other strategies that in general make communities more sustainable and livable, that we think should be sort of advocated and directed by the communities that are sort of currently most affected by them.
Excellent stuff. Thank you. Chris, I think this is a good question for you. Misty writes, are you aware of any efforts to monitor water temperature in North Carolina, including heat island effects at urban waterways, because many of our native aquatic species are adapted to a specific water temperature range?
I'm not aware of a statewide effort. I think we have some issues in our state with our water monitoring. Our state Department of Environmental Quality do amazing work in a lot of watersheds, but there are a lot of other watershed groups that are doing things on a more local scale, and the communication between those groups is perhaps not as great as it could be. And there are places that are not really monitored as much as they probably should be. So I don't think that's happening yet. I'm hopeful that at some point in the future, there have been some efforts trying to kind of tie all those different water quality monitoring groups together so that we can get better data and share across different groups, but I don't think that's quite solidified into a big thing. But a lot of you watching probably know, I'm an aquatic entomologist by training. It's a subject I really care about, and it is absolutely a problem if water heats up, that it can kill so many things in our bodies of water and completely change the way they work. It can also cause algal blooms and other things that can really impact water quality for human consumption. So it is an issue, and one that is perhaps not being addressed as well as it could be yet.
This is a project for the future. All right, how does the heat island effect impact local weather? Does it?
That is a very good question. It could. It definitely could. I'm not going to ever say that it's not possible. I'm not currently up to speed on if there's any current research going on about that or not, but I would definitely, ask you to look into that. I'm sure there are some resources out there on it, if there is any research going on about it.
And I will say this is one of the reasons that I love this particular program so much, is really excellent questions like that cut to the core of perhaps not even just the extent of knowledge of myself and my colleagues, but also the extent of knowledge that currently exists within the scientific community. And that's, again, part of the purpose and hope of being on here and talking about this project is there's a lot of different unknowns. And this is a really complicated issue. And I'm really looking forward to and really relish questions like that pose that type of question.
All right, excellent stuff. Well, Max, Myleigh, Chris, thanks for being part of the series today and sharing this cool project, hot project. It's a cool project. Anyway, it was great to have you learn about it. Send me, I'll make sure I'm going to drop information on how people can connect with this project into the video description as soon as we're done here. So that way, folks, if you need to, you can come back to this YouTube link and watch the presentation again. You'll also have access to the resources right there. They'll be in the chat and they'll be in the video description in the show notes. So you've got access to that. Next week, folks, we'll be back here, of course, again, Wednesday, noon Eastern at the museum's YouTube channel. Next week, we are going to be talking about the consequences and early warning signals of ghost forests in North Carolina's wetlands with Dr. Melinda Martinez from North Carolina State University. So we're going to be tackling climate once more. I hope that you'll be with us next Wednesday at noon. Make sure that you're subscribed to the museum's YouTube channel, of course. That way you'll know when we're bringing you the next live video, and we're doing all kinds of great stuff here all the time. Follow the museum on social media. We're at Natural Sciences on Facebook, Twitter, and Instagram, and stay up to date with what's happening with the North Carolina Office of Environmental Education by hitting up their website at eenorthcarolina.org or on Twitter at North Carolina EE. Again, thanks to today's very special guests. It was good to hear from you all and learn a little bit more about this project going on. I hope you get lots of folks participating all over, and looking forward to having you all back on the show when it's done so that we can learn the results too.
Chris, thank you so much. This was a real pleasure. Thanks to everybody for participating too.
Yeah, thank you.
Thanks.
All right. Keep your community safe. We'll see you again next time. Bye, everybody.